Yes, students. So after discussing the all calculative part of speed, velocity and acceleration, now you must have an idea of graphs also. Yes, this is the very major part of this chapter, motion. And why we are going to discuss this in here? Because we should have the representation capability also. Like we are having some mathematical part in our brain, and we are so calculative, we can calculate the speed, we can calculate velocity, and we can calculate acceleration, time, anything, distance, displacement, we can calculate all these things. But if it comes to the point that we need to draw the diagram related to the motion of a car or an aeroplane, okay, and we need to give an idea that in earlier time it was here, in next time it will be here, okay, that will be the artistic mode. Yes, if you are very fine in your art and craft studies now, then this will be the very easy part for you. Okay, some basics are here for the graph, that you need to know that the x-axis and y-axis here should be taken, okay, and time always be kept on x-axis, because the time interval we are not going to change, okay, time is in not our control, so the time will always keeps on changing with the particular interval of time. Fine. So whatever thing that is not in our control and it continuously changing with respect to itself only, that is a part of x-axis. Okay, we are keeping it as a base. Fine. So moving forward, we are having a distance time graph now. This is the first thing you are going to read in topic graph. Okay, so that distance time graph will gives you an idea related to the how much distance has been covered in how much time. So the first one here is the uniform speed. Okay, speed. Why speed is written here? Because dear all, speed is equals to distance upon time. Yes, so in this case you can see that the time will be taken here at x-axis and distance will be taken here at y-axis, and the slope in between these two things will give you an idea of speed. Okay, so here you can see that you are having all three things in a single graph. Okay, that is time on x-axis, distance, and whatever the slope you are having will be represented as the speed. So this is the part of uniform speed. Always you are getting the straight line for uniform speed. Why always a straight line? Because equal distance is traveled in equal interval of time in uniform speed. We are talking it as uniform because it is same in all manner. If equal distances is covered in equal interval of time, then we can say that it is a uniform speed. And non-uniform speed, what is it? If not equal distance, unequal distances has been covered in an equal interval of time, then we can say that it is a non-uniform speed. Okay, we have discussed thoroughly about it earlier. Let me tell you one more example related to this, that if a car is moving, again I am telling you the same example, okay, with like 5 meter in 1 second, and again 5 meter in 1 second, and again 5 meter in 1 second. That means in 1 second it is covering 5 meters. So that gives you an idea that it is again and again changing with the same distance. So if we are going to draw the graph for it, okay, let's suppose 1 second, 2 second, 3, 4. 1, 2, okay, I'm writing here 5 gap is there, 15, 20. Okay, so for 1 second it has been covered a 5 meter of distance. So we are marking it here. For another 1 second, again 5. So 5 plus 5 is 10. Okay, so another 1 second, 5 plus 5 is 10. So we are going to point it here. Okay, again in another 1 second, more 5 meters. So 10 plus 5, you are jumping here at 15 now. So at 3, you have to mark here at 15. So combining all these three, you are getting a straight line right now. Okay, but in case of non-uniform, you are not going to be through like this. You are not going to get a straight line. Let me tell you one more example. In 1 second, let's suppose it is covering 5 meter. Okay, and in another 1 second, let's suppose it is covering 4 meter. Okay, and in another 1 second, it is covering like 2 meter only. Okay, so the graph for it will be like this: 0, 1, 2, 3, 4, 1, and time, and this will be speed 1, 2, 3, 4, 5. So for the first starting 1 second, it was here. Okay, for the it has covered the 5 meter. Okay, now here for the first second, it is 4. Another one is 4, and for 1 second, one more second, it is covering 2 only. It is here. So this graph is like this. It is a curve. So whenever you are getting a curve, it might be like in downward direction or in upward direction, because the speed here is decreasing. That is why your graph is in down direction right now. But here, as you can see in the example, it is moving like this. So curve is moving like this. Earlier it was slow, and now it is increasing its speed again and again. So this is how our graph will help us to represent our speed without any calculations. So one more example of the graph that's shown us by the distance time graph is like this. Okay, if you are getting a structure like this, a graph like this, so what you are going to predict with this? Okay, I'm giving you time for thinking, but let me tell you first that the distance here is same with respect to time in all respect. Yes, so now the distance is same, but time is changing again and again and again. So can you tell me what kind of position is it at right now? What kind of motion is it at right now? Yes, it is at rest position. Definitely it is at rest position. See, distance, time. Time is moving. It is not in our control. It is moving again and again. 1, 2, 3, 4, 5, 6 seconds. Okay. Now 1 meter, 2 meter, 3 meter, 4, 5, 6, and let us suppose that it is standing on 5 meter position right now. 5 meter from any origin point. We are not considering that there is a 5 meter part on the earth globe somewhere in the earth part. Okay, no. Whatever you are thinking as the origin part, from there 5 meter distance, the body is at here. Okay, we are supposing it. So a straight line, that means in 1 second it is at 5 meter, in second again at 5 meter, in third second again at 5, at fourth part again here, fifth part again here. So it is not changing at all. It is at the same position. So we can say that this graph, whenever you are seeing like this one, so you can tell us that, ma'am, this is the rest position.